Hey guys, Card again with our review topic number 2, systems of inequalities. Systems of inequalities are two or more inequalities solved together to yield a solution set. A solution set is going to be a set of ordered pairs, x's and y's, that answer the system of inequalities. Now recall graphing inequalities from Algebra 1. We have dashed and dash lines that have a greater than or less than symbol. We have solid lines that graph greater than or equal to or less than or equal to equations. And we have to shade. When I do my graphing, I always check 0, 0 into my equations. And if I get a yes, I shade over where 0, 0 is. And if I get a no, I shade on the other side of the line. So for our first example, we have 2x minus y is greater than or equal to negative 2, and negative 3x plus 3y is less than 6. So when I look at this, I know that it's in standard form, so I'm going to use my mini table to graph my first line. So if I take 0 and I plug it in for x, 2 times 0 is 0. So I have negative y is greater than or equal to negative 2. I divide both sides by negative 1, and I get y is 2. You treat this inequality symbol as an equal sign when you're solving, and when you're graphing was when the inequality symbol will come into play. Next, I take 0 and I plug it in for y. So I get 2x minus 0 is greater than or equal to 2. Divide both sides by 2, and you get x equals negative 1. Now this symbol is greater than or equal to, so that means it's going to be a solid line. So I go down to my graph, I put a dot on 0, 2, and negative 1, 0. Again, I'm not using a ruler because I'm being very lazy. Now so far this is very similar to yesterday. We did dashed our solid lines, and now we have to check our shading. So I'm going to plug 0, 0 into my equation. So I have 2 times 0 minus 0 is greater than or equal to negative 2. 2 times 0 is 0, minus 0 is 0. So my question is 0 greater than or equal to negative 2? The answer to that is yes. So if I get yes, I shade where 0, 0 is. This is my cheating way of shading because it just saves a lot more time. Now, my next line, I'm going to repeat the exact same process to graph the bottom line. So I'm going to make my XY chart. I'm going to do it on this side. Now when I put 0 in for x, negative 3 times 0 cancels out. So I'm solving 3y equals 6. That means y equals 2. When I put 0 in for y, 3 times 0 is 0. So I have negative 3x equals 6. Divide by negative 3, and I get y is negative 2. So these are my next set of ordered pairs that I'm going to be graphing. This symbol, less than symbol, means I'm going to have a dotted or dashed line. So I'm going to go ahead and graph that. I have 0, 2, they overlap. And I have negative 2, 0. So again, I'm not using a ruler. Dashed lines are pretty easy to draw straight, which is very nice for me. Okay. Now, the next thing I have to figure out is where do I shade. So I'm going to check 0, 0 for my bottom line. So negative 3 times 0 plus 3 times 0 is less than 6. 0 and 0 gives me 0. So my question is 0 less than 6? And the answer to that question is yes. So for the pink, I'm going to shade below where 0, 0 was. So you notice on my graph, in this section, I should probably get a different color. Let me get pencil. In this section, all down here, I have blue lines and pink lines. This double shaded area is my solution set. What that means is that any ordered pair in this double shaded region will solve each of these inequalities. It'll be a true statement. So if I were to check 3, 0 into the top equation, I'll get a true statement. If I check 3, 0 into the bottom equation, I'll get a true statement. So that's what the solution set means. It means it's an ordered pair that will solve both of those equations. Okay. So we're going to repeat the same thing for the next one. I'm going to go a little faster this time. I'm going to do my mini table. 0 in for x gives me 0 for y, and 0 in for y gives me 0 for x. This is a little bit of a problem because I can't plot 0, 0, and 0, 0. So what I'm going to have to do I'm going to change this to y equals mx plus b. So if I have x plus 4y is greater than 0, I subtract x from both sides. So that gives me 4y is greater than negative x. And I divide both sides by 4. Be very careful when you're dividing with inequalities. If you multiply or divide by a negative number, you need to flip your inequality. I didn't do that, so I don't have to flip my inequality. Now from here, my slope is negative 1/4, and my y-intercept is 0. So this will be how I graph the line. Is it going to be dotted or solid? I look at my symbol, decide it's going to be a dot or dashed line. I call it dotted, but it really is a dashed line. Whatever you like. Just put a dot on 0. I'm going to count down 1, 1, 2, 3, over 4. Down 1, 1, 2, 3, 4. Again, I'm not using a ruler. Now the tricky thing about this is that not only could you not graph it in standard form, you also can't check 0, 0 because the line goes through 0, 0. So you're going to have to check a different point. You can pick any point you want. I'm going to check 1, 1 just because it's easy. So if I put 1 into my equation, I'm going to see if I get a true statement. So I have 1 plus 4 is greater than 0. 5 greater than 0. I ask myself, is that a true statement? And the answer to that is yes. So that means I'm going to be shading where that 0.11 is. My pen is dying. Okay. I have to repeat it again for the bottom equation. Do my little mini table. 0 in for x gives me negative 8/3 for y. Sorry, guys. And 0 in for y gives me 8/5 for x. If you do not know how to graph these fractions, use a calculator to convert them to decimal. And that will give you the decimals that you should do. So I'm going to plot these points. 0 and negative 8/3 is 2 and 2/3. And 8/5 is 1 and 3/5. And is it going to be dotted or solid? It's going to be dotted. I'm going to draw this line here. And I can check 0, 0 for this second line because it doesn't go through 0, 0, so that's no problem. So let's check 0, 0 because it's the easiest. Like I said, I check 0, 0 because it's the easiest, but if you really like the number 3 and 4, check 3, 4. It doesn't matter. I just find that 0, 0 is the easiest. I'm sorry. You know how I have this camera rigged. Okay. So I get 5 times 0 minus 3 times 0 is 0. And 0 is less than 8. That's yes. So I'm going to be shading where 0 is. Notice how this whole triangle up at the top here has my double shading, so that's my solution set. Okay, now lastly, I have this one at the bottom. So I'm going to go ahead and do this last one very quickly. 0 for x, I get negative 6. 0 for y, I get negative 6 over 4, which you should reduce, but I don't have enough space. It's going to be a dotted line, and so I'll plot that. I have 0, negative 6, and negative 6 over 4 is, oh, my phone won't stay. There we go. It's going to be a dotted line. And we're going to check 0, 0. All these keep being yes. I don't know why that is, but sometimes you get 0, 0 does not work out. You get a no, and that means you shade the other side of the line. So for this next one, do my table. Oh, a different color. Sorry, y'all. Change to pink. Oh, look at me, purple. 0 and 0. 0 for x, y is negative 5. 0 for y, x is 5. So we'll plot these. This is going to be a solid line. So and we're going to check 0, 0 on this side here. 0 minus 0 is less than 5. Again, that's true. So I shade this side of the line. So you can see I graphed 2 lines, and I've already set myself up to have this be sort of my solution set, but I have one more line. So I'm just going to grab another color really quick. How about green? So for y equals 7, I'm going to go to the y-axis, put a dot on 7. This is going to be a dotted line. So kind of overlaps my grid here. It's hard to see. And I'm going to check 0, 0. Now what's weird about checking 0, 0 is there's no x value, so just plug 0 in for y then. And is 0 less than 7? That's yes. So I'm going to shade. Now normally I would shade completely below the green line, but I've already noticed that my shading overlapped in this section, so I'm just going to shade this section so that it's really clear to me where my solution set is, which is in this weird shaped quadrilateral here, and that would be my solution set. So if I asked you, give me another point that would work for all 3 of these, you could tell me 1, 3, or you could tell me 4, 4, or something that's in this double shaded, 1, negative 2, something that's in that double shaded. Okay, so last thing is things to be aware of. There's a couple things to be aware of that we've already talked about. If the line goes through 0, 0, that's a big one.